All right, test 2 review. Test 2 review. So for this test, you will have an inspire. And I would definitely let the inspire do all the heavy lifting. Like, why wouldn't you, right? So I would, wherever I could possible, just let the inspire do all the work. Otherwise, why even have the calculator? Okay. So we're going to use substitution to find the y volume of this, the y value of the system. You can use the calculator to check. Sure. All right, so substitution. Right away, y is already by itself. We're going to plug it in to this y right here. So negative x minus 3y. So y is equal to, we can say, negative x plus 3. Equals negative 1. Okay. All we do is plug in y, right? Y was negative x plus 3. I'm plugging that into y. Let's distribute. So negative x, negative and a negative is a positive 3x. Negative 3 times 3 is negative 9. Equals negative 1. Combining like terms, right? Negative 3 or negative x and 3 make negative positive 2. Right? Negative x plus 3, positive 2. I'm going to add 9 to both sides. So cancels. So equals negative 9 plus 9, which is 8. Dividing both sides by 2 because I want to solve for x. Cancels on that side. This becomes a 4. So x is equal to 4. So I know one of the solutions is x equals 4. All right, we have to take that and plug that back into one of the equations because we want to solve for y. Therefore, I'm going to use the top one because it's already solved for y. If I plug in x, I'm going to immediately get a y to come out. So y is equal to negative x, which is 4, plus 3. Y is equal negative 1. So y is equal to negative 1. X is equal to positive 4. We could check our work on an inspire. I say we could. All right. We'll get to that part later. Rearrange, then determine the y value using elimination. Okay, so we're looking for the y value. Step 1, we want to use the elimination, so we have to make sure all of our variables match up. Notice x and y are over each other. That is not good. We cannot do the elimination method right now. So I'm going to rearrange these. Negative 4y plus 5x equals 3. On the bottom, I'm putting the 2y under the y and the plus 3x under the x equals 15. Okay, for this to work, elimination that is, you have to have an opposite sign. One has to be negative and one has to be positive. So right now I'm looking at a negative 4 and a positive 2. So I want this to cancel out. However, we're looking for we want the y value. So I could have the x's cancel out, and then I end up with the y value. Or I cancel out the y values to find an x value, then plug the x back in. That seems like a lot of work. So I want the x's to cancel right now. That's my thought. So I'm going to have to multiply the top and the bottom by something so that the x's cancel out. So I got to multiply the top by 3 and the bottom by 5. And you might say, well, why? Well, because of the coefficients, right? You multiply the other one by the coefficient in both cases. Now, one needs to be negative. So I'm going to multiply, let's do the top by a negative. It's completely random. I just chose the top for no reason. So this is going to, so when we rewrite it, when you distribute the negative 3 to everything, that's going to be positive 12y. Negative 15x negative 9 equals negative 9. All right, distributing the 5, 10y, 15 positive x, and then 5 times 15. 4 times 15 is 60, so 75 equals 75. Okay, now when we add, you always add. The 15s cancel because we designed it that way. 12y plus 10y is 22y. And then negative 9 plus 75, right? You're adding them together. You're going to get positive 66. All right, you're dividing both sides by 22 to solve for y. Cancels. This is going to be 3. Y is equal to 3. We don't even need the x. Why did I not need the x? Because the question asked us determine the y value. It don't say nothing about the x value. So I want to find the y value using elimination method. I did that. All right, number 3. What is the solution of the system of equations? X minus 7y equals 6. Negative 3x plus 21y equals negative 18. Hint, solve using substitution or elimination. I'm going to go with elimination. That's just the one that I like. Okay. First thing I see is that I can multiply the top by 3, which will make this a 3x, and it'll cancel in the bottom, right? I'm looking for same coefficient, opposite signs. How can I make that? Well, let's do it like this. 3 times x is 3x. Negative 21y plus 18. Okay, so when you add, this is going to cancel. This is going to cancel. So when both variables cancel, we got 0 equals 0 because they cancel. 0 equals 0. This is infinitely many solutions. This is a special case. So 0 equals 0. Infinitely many solutions. It's rough. You got to catch that. So if had this been a number, right, had that been a number, it is no solutions. 0 equals a number is no solutions. So keep that in mind. I'll just write that off to the side. 0 equals any number other than 0, no solutions. Okay. A high school's enrollment is 500 students. It includes freshmen, juniors, and seniors. Okay. Right away, I know one of my equations has to be a total of all of them, right? X plus Y plus Z equals 500. Twice the freshman enrollment, so 2 times Y, is 3 times the senior enrollment, so 3Z. The total number of juniors and seniors, so Y and Z together, is 200 more, so that means plus. That means plus the number of freshmen enrolled, so X plus 200. All right, there are my equations. Do we want to know how many seniors? So we're looking for Z. I'm looking for Z. Rearrange and use the calculator. All right, bet. So for this to work, all your variables need to be on one side of the equal sign. You can't have variables on opposite sides of the equal sign. Everything's got to be to the left, typically, and then all your non-variables, strictly numbers, got to be to the right on the other side of the equal sign. So far, x plus y plus z equals 500. All right. Another tip is that all your x's have to be aligned. All your y's have to be aligned, and all your z's have to be in a column. If you're missing a variable, then that's going to be a 0. Because right now we're building a matrix, if you haven't already put it together. We're going to have to build a matrix. So this is minus 3z in the second, minus 3z. So we're going to get 2y minus 3z equals 0. Because 0 is what's left on the right. All right, very important. I got to put a 0 in for the x. Got to put a 0 in for the x. We're going to subtract x. So we get minus x plus y plus z equals 200. Okay, for this to work in the calculator, we have to make a matrix of just the coefficients and the answers. So we're going to have 3 rows, 4 columns. So 1, 1, 1, 500. Right, it's understood that there's a 1 here, a 1 here, and a 1 here. That's where those 3 ones come from. Then a 0, 2, -3, 0. -1, 1, 1, 200. Okay, now, for us to figure out what x, y, and z are, and to answer this question, what z is, you have to use the function RREF. Then you have to put a parentheses. So RREF, reduced row echelon form. You could use the quick key, or like the quick function on the Inspire, menu 7.5, right? Menu 7 and then 5. Menu 7.5, and then it'll prompt you. It'll ask you how many rows and columns. We want 3 rows, 4 columns. Right, X, Y, Z, and then the answer column, and then 3 rows. So let's go to the Inspire. Feel free to pause the video and type in your answer. But we see that when you do this, Z is going to be equal to 140. 140 seniors enrolled. 140. It's the bottom answer. It's always, they're in order, right? X, Y, and Z, it's the bottom answer. I can't show you, but it's the bottom answer. Bottom right corner. Right? On your calculator, it's going to look, I guess I can show you. Disregard the 1s and 0s. We don't really need to know what that is at the moment. So in your answer, on your calculator, you get this, right? Long story short, this is your X answers, right? X is equal to 150, Y is equal to 210, and Z is equal to 140. So 140 is the Z answer. 140, X, Y, and Z. Okay, number 5. Is the ordered pair 3, 5 a solution to the system below? Show how. All right, so 3, 5. This is your X and this is your Y. So what we're going to do is I'm going to plug in X and Y and see if the statement is true. So 3 times 3 is 9 minus 5, which is 4. Now, is 4 greater or equal to 12? That is the question. No, it's not. This is false. It's false. So I don't even need to check the second one. Right? I don't even need to check the second equation. The reason I don't need to is because it was already false for the first equation. Had it been true, well, then now I got to check the second equation. Because if 3, 5 is a solution, then it's going to be true for both systems or for both equations. But it's not. It's false for one. Once the moment it's false, not a solution. Not a solution. There's no reason to even show the next one. Because even if I show the next one, and let's just say it's true, that means nothing because I got a false reading in the first one. So it's false. All right, number 6. You have $125.50 in quarters and dimes. Okay, so I can already see where this is going. We can call this Q and call this D. We can use X and Y, but whatever. So there are 1,102 coins all together. So all my quarters, all my dimes is 1,102 coins. So right away, Q plus D equals 1102. Write a system of equations. Write a system of equations can you use to find the number of each type of coin you have. Okay, so we're gonna write a system of equation that we can use to find the number. Okay, so there's one equation, right? The total number of coins. Now I need a money piece because they gave me a money figure. So I need some sort of equation that has money in it, right? The other equation had to do with the total number of coins. So now we need one that has money in it. So this is equals 125.50. So Q quarter is 25 cents. So 0.25. Dime is 10 cents, 0.1. That's a D. Okay, so now I have a system where I can make a matrix. 1, 1, 1, 1, 0, 2. Right? It's understood that there's a 1 here and a 1 here. 0.25, 0.1, 125.5. Okay, we have our matrix. We go to our calculator, RREF, menu 75, whichever weapon you like, and we hit it. Feel free to pause the video. Plugging it into the Inspire, you get the answer 10, 102, 01, 1000. So this means which one's a quarter and which one's a dime. That's really what it comes down to. So remember, that first row is going to deal with the variable of the first column. So this is Q. Then the second row is going to be the second column. So this is going to be the dimes. So there was 102 quarters, 1,000 dimes. Okay. Second page, use the calculator. Okay. What is the value of X for the system of the equation to the right? Oh boy. Okay. So look, we have to turn this into a matrix. -1, 2, -3. 3, 1, -1. -2, -1, 2. 19, 5, -7. All right, and all the X's, all the Y's, all the Z's were lined up. I should have mentioned that. All right, we take our matrix, turn the system into a matrix, put it into a calculator, RREF, and we're going to look at the very top row that comes out, the top right number. So calculator time. All right, looking at our answers. So we want just the x, right? We want just the x. So the inspire is going to give us 1, 0, 0, negative 1. It's going to give you more stuff also. 0, 1, 0, 4. All this irrelevant right now. 0, 0, 1, negative 3. Okay, so here's the matrix, right, that the inspire spits out. So just know that this is your x, your y, and your z. So we want x is equal to negative 1. We don't care about the rest. Only because they tell us to only find the x. All right, so I only care about x equals negative 1. All right. Number 8. Ronald Reagan Theater is selling tickets for the upcoming play. There are 3 categories. Adult, student, and child. So A, S, and C, apparent, like you could use. So notice the way this is set up. So Carl buys 2 adult, 1 student, 3 child for $70. Jane buys 4 adult, 2 students, 1 child for $110. Sally buys 6 adult, 2 students, 3 child for $162. How much does each type cost? So notice adults, students, and childs are already lined up. So really, we just got to grab the numbers in order. 2, 1, 3, 70. 4, 2, 1, 110. 6, 2, 3, 162. Now when you go into so notice this is A, this is S, and this is C. When your answers come out, it'll be in that order, right? A, S, and C. So this is the setup. We're going to use the calculator. Remember using RREF, and always put the parentheses. If you don't put the parentheses, you're going to get an error saying something's missing. So RREF parentheses, and then put in your 3x4 matrix. Right? There's a 3 row by 4 column. All right, going to the inspire. We see that the answer that comes out 1, 0, 0. 20, 0, 1, 0, 12, 0, 0, 1, 6. All right, remember A, S, and C. So how much does each type cost? Adult, $20. You can't see it. Student, $12. Child, $6. So 20, 12, and 6. If 2 lines of a system of equations are parallel, then what is the system's solution? So 2 lines that are parallel never intersect. Excuse me. So no solution. If 2 lines coincide, they end up being the same line. So if here's a line, and then, oh, here's the same line. They coincide. We have infinitely many solutions. Number 10. Solve the given system. What is the value of y, or what is the y value? Use a calculator. Okay, well, this is just like the problems we did up here, but even better because there's no word problem. It's just all the x's are lined up, all the y's, all the z's, and then all the answers to the right. So in the calculator, we're just going to grab the coefficients. 2, 4, negative 1, negative 1, 5, 4, negative 4, negative 1, 2, 3, and then 15, 10, and negative 20. All right, this is a 3 row by 4 column, right? X, Y, Z in the answer, 4 columns. We're going to go to the calculator, RREF this, and then use the parentheses, right? RREF, parentheses, and then the matrix, 3 by 4, 3 by 4. All right. Okay, we see that the answer that comes out is 1, 0, 0, 5, 0, 1, 0, 0, 0, 0, 1, negative 5. Okay. This is my X, this is my Y, this is my Z. The Y value is Y equals 0. It's kind of nice. It's kind of nice. Number 11. Okay, so this is a graphing one. We got pictures. Write a system of linear inequalities for the graph below. All right. So this is going to be three equations. There's 3 equations. So let's try to kind of see through the clutter. Okay. Here's the X and Y axis. Right? The X and Y axis. So the X axis is this one. And then the Y axis is this one. So I really don't care about those. But I can see where the origin is. So, okay. In blue, this is what I'm gonna write. So X is equal to, right? I don't care about the red lines. The red lines, I drew those so I could see where the origin is. That is for counting purposes. So the blue line, the first vertical blue line, is a vertical line. So X equals a number. X equals a number is going to be X equals 1, 2, positive 2. But it's shaded to the left and it's a solid line. So it needs to be X is less than 2, less than or equal, right? It's shaded to the left, less than, and then solid or equals. All right, the next line I want to do is the green one. So this is going to be Y equals. And Y equals what? Y equals -2 because it's below the x-axis. So Y equals -2. And it's shaded above. So I want greater than because it's shaded above. So above, greater than, solid line or equals. All right, the last one. This one's going to be interesting. It goes through the origin at a 45-degree angle, right? Up 1 over 1, up 1 over 1, up 1 over 1. So this is actually Y equals X. Y equals X is this 45-degree line. And it's shaded below, so we have to do less than, below, less than, and then or equals, so it's solid. So here are my 3 lines. So what rules was I just using? So as long as you have your variable to the left, as we did here, if you have less than, this is going to be, you shade below or to the left, depending if it's an X. Right. If it's greater than, you shade above or to the right. Again, depending if it's an X. Less than or equals is a solid line, as is greater than or equals. So both of these are solid. Strictly greater, strictly less than is dotted. All right, those are the rules that I was basically stating. And just remember that X equals a number is a vertical line. Y equals a number is a horizontal line. Okay. All right, this is kind of hard to see. So let's see. This is the x-axis or y-axis. This is the x-axis. So what do I want? First thing I see is this x equals a line right here. So this is x equals. Oh, look. I wonder if that was the case on the last one. Oh my goodness, it was. All right. So hold up. The blue line was C. My bad. I didn't even catch that till just right now. The green line is A. And then the yellow line is B. Okay, let's pay attention to that. That's my fault. My fault. Okay. So here, the blue line is going to be C. So this is x equals a number for sure. X equals a number. What number? Positive 2. We're shading to the left. So this is less than or equals. Because it's solid. B, call it the green line. This is that y equals x line again. Right? It's the 45-degree angle. Y equals x. But it's shaded to the left or above. So we're not necessarily left. It's above. Like we're shading above. So this is greater than. This is greater than. Right? Y greater than x. So y equals x is my solid line, and I shading above it. What notes did I have down here? So if it's greater, it's above. Okay, so let's fix these notes ever so slightly. So we shade above when it's the y, right? Y greater than something, we shade above. If it's x greater than something, right? X is greater than some number, we shade to the right. Y less than, we shade below. X less than, we shade to the left, right? So, right, X and Y have to be on the left-hand side of for these to work. Okay. Okay, A. The red line, or let's just say the gold line. So this is y equals a number. It is what number? -2. -2. And we're shading above. So greater than. Greater than or equals. I'm going to have to watch that a couple times. My bad about the confusion. Okay. If a system has parallel lines, what must be true about their slopes? Think back to geometry. Parallel means same slopes. Their slopes must be the same. Use the system below to answer the questions 14 through 17. Okay, write the coefficient matrix. Remember, coefficient is just the variables. Right, the numbers in front of the variables. All the x's, all the y's, all the z's are lined up. So this is going to be 2, -1, 4, -1, 3, 2, 4, -2, 3. Just the variables. The constant matrix, this is the answers. So 1 by 3, or 3 by 1 rather. 3 rows, 1 column. 19, -7, 37. All right, the answer matrix. So this is kind of a weird wording. So the answer matrix is when you put this in a calculator and you figure out what the answer is, right? Like the actual answer, meaning the X, Y, and Z, like afterwards with all the ones and zeros. So what I'm going to do is you have to put these together. 2, -1, 4, -1, 3, 2, 4, -2, 3, and then the answers 19, -7, 37. So actually I misspoke. This is the answer matrix, right? It's the coefficient and the constant matrix put together. This is the answer matrix. When you put this into a calculator, right? When you put this into the calculator with the feature RREF parentheses this matrix, we get, solving for Z, it's going to be the bottom one. So feel free to pause the video. We get 1 0 0 0 1 0 0 0 1 8 1 1. Okay, so our answers are X equals 8, Y equals 1, Z equals 1. So Z equals 1 is our final answer. Solving for Z. Okay, last page, let's go. To solve the system of equations below using the elimination method, what would be some options for the first step? All right, so one option. So again, it's like, what do you look for? What are you even looking for? I'm looking for the coefficients that are the same and have opposite signs, right? One positive, one negative. So I don't see anything that's the same, but I do see a positive and a negative, right? This is positive and this is negative. So that's what my eyes go towards. So I'm like, okay, I'm going to work with Y on this. So now I need to make them the same coefficient. Well, it just so happens if I multiply the bottom by 3, I'll make a -3 in the bottom. So what's it asking? What would be some options for step 1? Okay, one option would be to multiply the bottom. I mean, I don't know what they want me to write out, but multiply the bottom, or multiply equation 2 by 3. Then cancel the y's, the y variables. Or, okay, so the next one would be, if I don't want to cancel out the y's, I want to cancel out the x's. So I'd have to multiply. So look, we want to cancel out the x's. So if the bottom one was -7, that would be, that would be best. So equation 2 by -7. And then cancel out the x. So we're going to, quotations, right? Copy the thing above. Copy. Cancel out the x variable. The x variable. Okay. If we're doing the substitution method, what would be the best first step? Subtract 2y. Okay, so look, we're looking. The thing we're looking for is that, is there a variable all by itself? Yeah, it is. It's right here. X is all by itself. So that's the thing I'm going to try to isolate. So I have to add 2y to both sides. So that's what I'm going to do. That would be the best first step option. Add 2y to both sides of equation 2. Okay. Solve using elimination. Write the possible resulting 2x2 system after eliminating z. Use your notes asking for step 3. Okay, so in a 3x3 or in an XYZ, right, a 3 variable matrix, there's a 5-step process. This is asking for step number 3, right? You're going to do step 1, step 2, and then step 3 is what it's asking for. And they want you to eliminate z. So what this is saying is I have to choose 2 of these. So A, B, and C. Of the 3, so that z will cancel. So I'm looking for opposite signs in z. So right here. So I'm going to use A and B. So when I use A and B, it's going to be 5x plus y minus z equals 6. Right, that's A. B is x plus y plus z equals 2. So when I add these up, the z's cancel. So I get 6x plus 2y equals 8. Okay, now, because I chose A and B, I must now choose C. I'm forced to use C. I have to, because I didn't use it in the other one. So 3x plus 2y plus z is equal to 6, right? That's C. Now, I have to choose one of the other ones, right? A or B. But I want to choose it so that z cancels, right? Because z canceled in step 1, right? This was step 1. I'm doing step 2. I need to choose A or B so that z will cancel. So I'm going to choose, so this is positive. I need the negative one. So I'm going to choose A. So 5x plus y minus z equals 6. So when we add, the z's cancel. 8x plus 3y equals 12. So step 3, we stack our answers on top of each other. 6x plus 2y equals 8. 8x plus 3y equals 12. So the possible resulting 2x2 system right here, this is it. This is the possible. All right, now it says solve the system in any method. What is the value of z? Okay, so if you were to finish this by hand, step 4 would be, well, step 3, we would complete step 3 and eliminate a variable. In step 4, we would take that variable, plug it back in, figure out the other variable. So now we have x and y, right? Because at the end of this, I should know both of these variables. And in step 5, we would figure out z. But we have a calculator handy. So I'm just going to put these into the calculator and then choose the bottom line. So the matrix is going to look like 5, 1, 3, 1, 1, 2, negative 1, 1, 1, 6, 2, 6. And then I'm going to RREF this matrix with the parentheses. So the result comes out 1, 0, 0, 0, 1, 0, 0, 0, 1. That's a 0. 0, 4, 2. So the z value is the last one. Z is equal to 2. Oh, you couldn't see it. Sorry. Z is equal to 2. Last question. Let's go. This is going to be write 2 points that are not a solution for the system in the right. So for not a solution anywhere not on the solid line, right? Not on the solid. And not in the gray. So whatever satisfies that. So look, we can go here. This is 1, -2. Now, you could get fancy. You could get fancy and put one right here, right? It's on the dash. It's definitely not in the gray. It's on the dash, not the gray. So this could be 1, 2. 1, 2. You know what's crazy? So any of these. What about this one? 1. Oh no, it's definitely not. Can't be on the solid. Can't be on the solid. Well, no, that's the X. That's the X-axis. This one's the X-axis. So yeah, it could be on this solid line. This is the X-axis. It's not. So really, any of these, right? I feel like you get the picture. So any of these right here. You choose any of these, you're good. Now you may say, what about this one right here? It's on the solid line. Yeah, but it's not in the gray. Right? It's like it has to be on the solid and the gray. Solid and the gray. Notice where I didn't put one. Right? It'll be there. So all the places I didn't put one. So it could actually be on these also, because there it's on the dashed. Dash is fine. So yeah. Right, this one would be one too, because it is still on the dash line. That vertical line is a dash line. That's crazy. Okay. I mean, you have many to choose from. Many to choose from. The point is, it's a solution when it's on the solid and the gray, or the solid that touches if it's in the gray, it's definitely a if it's in the gray, it's definitely a solution. But it's when it's on the border, like that edge, that's when it gets kind of confusing. If it's on the border and the border is solid, it's a solution. If it's on the border and the border is dashed, it's not a solution. All right, so hopefully this is helpful. Let me know what you guys think, and I'll catch you in the next video.